Hey everyone, and welcome back to Talk Tensors. We're diving deep today into a paper that's making some serious waves in the 3D generation world.
Oh, absolutely. It's called 01 to G, Taming Pre-trained 2D Diffusion Model for Direct 3D Generation.
Catchy title?
It is, and it's some pretty fascinating work, especially if you're at all interested in, creating these realistic 3D models just from a single image.
Okay, so single image to a 3D model. For our listeners who maybe aren't super familiar with this area of research, what's the big problem that this paper is trying to solve?
Well, the biggest challenge in 3D generation has always been datasets, or rather the lack of them.
Okay, so not enough data to work with.
Right, we're talking about massive, high-quality 3D datasets, and those just haven't been available. Think about how many images we have out there on the internet compared to 3D models.
Yeah, it's not even close, right?
It's a huge gap. So this paper is presenting a really clever way to bridge that gap.
How so?
By using something that we already have a ton of 2D images.
Okay, so instead of needing thousands or even millions of 3D models to train an AI, this paper is saying, hey, let's use what we already have tons of.
Exactly. 01 to G leverages the power of these pre-trained 2D diffusion models, the kind that have already been trained on vast amounts of image data.
So they're really good at image stuff.
They are. They're incredibly good at generating images.
So they're using AI that's already an expert in understanding and generating 2D images as a starting point to get to 3D generation.
Yeah, that's the idea. And it's pretty neat. But how do they make that leap from 2D to 3D?
That's what I was going to ask.
Well, the key is a 3D representation technique called Gaussian Splats.
Gaussian Splats?
Yeah, have you heard of these?
I have not.
Okay, so imagine you're building a 3D model, but instead of using pixels like you would in a photo, you're using these tiny little 3D blobs, and these are called Gaussian Splats.
Okay, so like digital clay almost.
Yes. Like digital clay that the AI can mold into any shape.
Okay, I'm starting to visualize it.
Right.
But how do you connect those digital clay blobs to a 2D image?
That's where it gets clever. 01 to G takes these Gaussian splats and decomposes them into a bunch of different multi-view images.
Multi-view images.
Yeah, so each of these images represents different attributes of the splat, like its color, its size, the rotation, and even its position in 3D space.
So you're basically taking this 3D object and breaking it down into a set of 2D images that describe its parts.
Yeah, you got it. So instead of trying to generate the super complex 3D model all at once, they're generating these simpler 2D splat images that collectively represent the 3D object.
And because those images are 2D, they can then use those powerful pre-trained 2D diffusion models that we're talking about.
Exactly. They use a model like Stable Diffusion, which, as you know, is known for generating some pretty amazing images to learn how to create these splat images.
Okay, that makes sense. So it's like they're teaching Stable Diffusion to work with a new kind of artistic material. Instead of paint, it's now working with these digital clay blobs.
It's a great analogy. But it's not quite as simple as just feeding those splat images into Stable Diffusion. There are a couple of extra steps involved to make sure everything works seamlessly.
Okay, what kind of tricks are we talking about?
Well, first they fine-tune a part of Stable Diffusion called the VAE decoder.
VAZ decoder, what is that?
So think of it as giving Stable Diffusion a specialized training course to understand the unique characteristics of these splat images, which are quite different from natural images.
Okay, so they're basically teaching Stable Diffusion a new language.
Yeah.
One that's specific to these Gaussian splat representations.
Exactly.
I like it.
Yeah.
But I'm guessing there's more.
You're right. There's another important piece to the puzzle. How you ensure consistency across different viewpoints.
Right, because we're trying to create a whole 3D object from a single 2D image, which means you need to be able to generate those splat images from different angles.
Absolutely. You can't just copy and paste the same splat image over and over again. A 3D object looks different from every angle, right? So they introduce these really innovative attention mechanisms within Stable Diffusion. One is called cross-view attention, and the other is cross-attribute attention.
Okay, so break those down for me.
Yeah.
What do those attention mechanisms actually do?
Think of cross-view attention as a way for the AI to make sure that, say, the front and side views of a car it generates actually match up.
Makes sense.
And then cross-attribute attention makes sure that the size, the rotation of each splat, they all make sense within the context of the overall 3D object.
So it's like the AI is constantly double-checking its work, making sure that all the different pieces of this 3D puzzle are fitting together in a logical way.
Exactly.
That's really clever. So once you have all these splat images generated from different angles, how do you actually stitch them together to create the final 3D model?
It's kind of like assembling a 3D puzzle, where each piece is one of those splat images.
Okay, I like that.
They fuse these images together to create the complete 3D Gaussian splat representation, and then that can be rendered using existing techniques to create the visual 3D model.
So it's a multi-step process. But ultimately, it allows you to go from a single 2D image to a full-fledged 3D model.
Yeah.
And it does this all by cleverly leveraging all that existing 2D image expertise that's already out there.
Yeah, exactly.
This is really fascinating stuff. But before we get too carried away, let's step back for a second and look at what led up to this breakthrough. What were some of the limitations of those earlier approaches to 3D generation that made 01 to G such a significant advancement?
Well, one of the earlier methods was something called score distillation. Basically, what they were trying to do was extract 3D knowledge from these pre-trained 2D diffusion models by comparing their outputs to rendered images of 3D scenes.
Okay, so like trying to learn how to sculpt a 3D object by only looking at photos of it from different angles.
Yeah, exactly. You might get a sense of the overall shape, but the finer details would be lost.
So you're saying score distillation was kind of like trying to reverse engineer a 3D understanding from these 2D diffusion models that were really designed to just generate images.
It was, and it was challenging. And it came with some pretty major drawbacks. Like, it was really computationally expensive.
Sort of needed a lot of processing power.
Yeah, a ton. And it would take a long time to generate a single 3D model. Plus, it was really prone to errors, especially when you were dealing with complex scenes or objects with a lot of intricate details.
So not exactly the most efficient or reliable approach.
Not really, no.
Okay.
So researchers then shifted their focus to something called two-stage methods.
Okay, two-stage methods. What's the idea there?
So in the first stage, you generate multiple 2D images of the same object from different viewpoints, kind of like taking a series of photographs.
Okay, so like a 360-degree view almost.
Yeah, you could think of it like that. And then in the second stage, you'd take all of those multi-view images and try to reconstruct a 3D model from them, kind of like piecing together a 3D puzzle using these images as guides.
That makes sense intuitively.
Okay.
But I'm guessing there were still some issues with this multi-view approach.
You're right, there were some hurdles. While it was a step in the right direction, it often struggled to achieve that level of detail and accuracy that you need for truly realistic 3D models.
So what would go wrong?
Well, the generated models would often end up with blurry textures, or the shapes would be distorted. Sometimes there would be inconsistencies between the different views. Imagine trying to build a house, but the walls don't quite meet up properly. Something's just off.
So even slight misalignments between those 2D images could throw off the whole 3D reconstruction.
Exactly. And that's a big problem if you're aiming for high-fidelity models. But that's one of the areas where 01 to G really shines, because it directly generates those 3D Gaussian splat representations. It doesn't need that error-prone multi-view generation step.
So it streamlines the process.
Yeah, and it cuts down on the chances of those inconsistencies creeping into the final 3D model.
So 01 to G kind of eliminates a major bottleneck in that traditional pipeline.
That's a great way to put it. It's a big deal both in terms of efficiency and in terms of accuracy.
But we did touch on the fact that 01 to G still involves generating multiple 2D splat images.
Right.
So how is that fundamentally different from those earlier two-stage methods that also relied on those multiple views?
That's a good question. The difference is that in 01 to G, those splat images aren't just independent snapshots from various angles. They're all linked together to that 3D Gaussian splat representation from the very beginning. They're working together to create this unified and coherent 3D model.
So it's the difference between taking separate photographs of an object versus capturing a 3D scan of it. That scan captures the shape and the structure of the object in a more holistic way.
Exactly.
Okay, that's a great analogy and really helps clarify why 01 to G is such a significant departure from those earlier approaches. So we've talked about how this approach is more efficient, more accurate. But as with any new technique, there are bound to be challenges. What were some of the hurdles that the researchers had to overcome to make this work?
Well, one of the biggest challenges was actually bridging the gap between natural images, the kind that 2D diffusion models are trained on, and those Gaussian splat representations.
Right, because they're very different kinds of data.
Yeah, it's like trying to communicate with someone who speaks a totally different language. You need to find a way to translate between those two worlds.
So it's a language barrier of sorts.
Exactly. And they used a really clever two-pronged approach to address this. First, they fine-tuned the VAE decoder.
Okay, remind me again, what's the VAE decoder?
It's part of the Stable Diffusion model, and it basically helps translate between the latent space representation of the image and the actual pixel values.
So they're giving Stable Diffusion a crash course in Gaussian splat language.
Precisely. But there's another hurdle to overcome: ensuring consistency across different viewpoints and attributes within each splat image. Remember, we're generating multiple splat images to represent different aspects of that 3D object.
Right, like color, size, rotation.
Exactly. And all of those images need to work together to create a cohesive 3D model.
Otherwise, you end up with a jumbled mess.
You got it. And that's where those attention mechanisms come in cross-view attention and cross-attribute attention. These mechanisms allow the model to understand the relationships between different viewpoints and attributes and ensure that everything lines up correctly.
So it's like the AI is constantly cross-referencing its work, making sure that the front view matches the side view and that the color size and rotation of each splat are consistent with the overall 3D object.
Exactly. It's all about making sure the different pieces of the 3D puzzle fit together seamlessly. And those attention mechanisms are really what allows 0, 1 to G to achieve that level of realism and accuracy.
So they prevent the AI from creating a Frankenstein's monster of a 3D model.
Precisely. No mismatched parts, no inconsistent details.
This has been a truly fascinating deep dive into the technical nuances of 0, 1 to G. It's clear that this approach has the potential to revolutionize how we create and interact with 3D content. But I'm also curious about the broader implications of this technology. What kind of exciting new possibilities does 0, 1 to G unlock? Let's shift gears and step into the realm of what if? Where could this technology lead us in the future? What are some potential applications that have you excited?
Oh man, so many possibilities. One area that I'm really excited about is how this could democratize 3D content creation. Right now, creating high-quality 3D models, it's a pretty specialized skill.
Yeah, you need expensive software, powerful computers.
Exactly. It's kind of an exclusive club. But imagine a future where anyone with a smartphone could just snap a photo of something and boom, instant 3D model. That's the kind of accessibility that 0, 1 to G could bring.
That would be incredible. I mean, think about the applications for education. Students could create 3D models of anything historical, artifacts, scientific specimens. It would make learning so much more engaging.
Oh, absolutely. And it goes way beyond education. Think about e-commerce. Imagine being able to see products in 3D online.
Yeah, you could rotate them, zoom in, examine them from every angle before you buy.
No more guessing about whether that couch will actually fit in your living room.
Or if that shirt will actually look good on you.
Exactly. You could try it on virtually.
And what about social media? Instead of just sharing photos, people could share interactive 3D models.
Oh, yeah. It would be like taking the internet from 2D to 3D.
The possibilities really are endless. But okay, let's think even bigger. What are some of the more futuristic what-if possibilities that get you really excited?
Okay, well, one that comes to mind is combining this technology with VR and AR.
VR and AR.
Yeah, so imagine being able to take a photo, generate a 3D model, and then pop on a VR headset and walk around inside that model.
So you could take a photo of your living room, generate a 3D model of it, put on the headset, and actually walk around your virtual living room.
That's the idea. Or you could use AR to overlay a 3D model of a new piece of furniture onto your real living room. See how it would look before you buy it.
Wow. Okay, my mind is officially blown. This is like sci-fi stuff. But before we get too carried away, we should talk about the potential downsides too.
Oh, for sure. Any technology this powerful has the potential for misuse.
What kind of misuse are we talking about?
Well, think about deepfakes. Someone could use this to create incredibly realistic 3D models of people and then use them for, misinformation or propaganda.
That's a scary thought.
It is. We've already seen how damaging deepfakes can be in 2D, and in 3D it could be even worse. So it's super important that we think about the ethical implications of this technology right from the start.
Absolutely. We need to make sure it's used responsibly. But even with the potential risks, I'm still incredibly optimistic about the future of 3D generation. 0, 1 to G is a huge step forward, and I can't wait to see where it leads.
Me neither. It's an exciting time to be working in this field, and I think we're just scratching the surface of what's possible.
Well, that wraps up our deep dive into 0, 1 to G. Thanks for joining us on Talk Tensors. We'll be back next week with another fascinating paper and another deep dive into the world of AI. Until then, keep exploring, keep learning, and keep pushing the boundaries of what's possible.
See you next time.